This is related to your implicit derivatives. Now both x and y are implicitly defined. So what that means is x is really a function of t and y is really a function of t, which means the derivative of x is not just the derivative of x, you have to add this dx dt to the end. And the same thing with y, there's this dy dt. So in short, like basically what you do here is we're looking at this equation, y equals x cubed plus 6. When you take a derivative of y, that's dy dt.
Mm-hmm.
When you take a derivative of x cubed, it's 3x squared, but then you add in this dx dt. That's the little wrinkle. Like usually you just add it with the y, but now you add it with the x.
Okay.
Does that make sense?
Yeah, what only in this kind of
Yes, yes. Which I know why, why is that? We can talk about that. But notice that they give you a dx dt. So you always want to think about like this is an SAT, ACT. Like, why are they giving me that? Well, because you need it.
okay.
All right. So now you're putting x equals 5 in. So it's 3 times 5 squared times 4. 5 squared is 25. 3 times 5 is 75 times 4 is 300. So maybe double check that just in case that I do make mistakes, not just in math. We all make mistakes, right?
Yeah. Yeah, it's 300.
Right. So let's look at the next question here. Boy, this is that word problem that goes along with. So these are called related rates. If you care
Mm-hmm.
to know. So it says the original 24-meter edge length x of a cube decreases at the rate of 2 meters per minute. So a cube, you haven't seen a cube in a while. All the lengths are the same, x, and x. Okay, so thing one that you have to do in all these problems is write the equation. And you're like, the equation for what? In this case, it's the surface area. So one of the faces is x times x. Okay, but there's 6 of them because it's a cube. So the surface area, SA, is 6x squared, like that. So you have to write the equation. Like they're not going to give it to you. You're going to have to figure that out yourself.
Okay.
So in this case, because it's a cube, you can remember it's always 6x squared. If you get a note sheet, maybe you put that down on there. Yeah, up to you.
Mm-hmm.
All right, now the derivative, and you can just go SA prime, like you don't have to do the dy dt or dx dt,
Okay.
but this is 12x dx dt, like that.
Okay.
Is that okay?
Yeah, so A, they want you to write.
Well, this is the answer to A,
Okay.
but
Okay.
you can't get there unless you can write the equation and then do
Mm-hmm.
the derivative. Like in the previous problem, they gave you the equation.
Mm-hmm.
And so now they're not giving you the equation.
Okay.
You have to write it.
Mm-hmm.
Yes. Questions on that?
No.
Okay. So the next part here, let me snip this in, is this right here. Now we need the equation for volume. So
Okay.
volume is x cubed or x times x times x. Oh, no, I'm sorry. I messed up this previous part. See how it says decreases?
Yeah.
That means it's -2. So that means down here it's -2 or -144.
Okay.
Okay, sorry. So that does change that answer there. Now the
Yeah.
volume, it's x times x times x or x cubed. So this time v prime or dv dt is 3x squared times dx dt. So again, x is 6, the x dt is -2. That doesn't, that's the rate of change of the side. So 36 times 6, -216 maybe. Please double check that.
Yeah. -216.
Right. Okay, so next question, number 20. Again, another related rate here. And if you, I know it's, I always, the pictures, if you could ever do like half screen on the snips, they just come in a little better. So not
Okay.
so wide, but this is fine. I mean, it just, it's a preference.
Mm-hmm.
So on a circular plate, you have to know what the formula for an area of a circle is. Its radius increases at a rate of, so whenever you see something increases or decreases rate, that's an implied rate, drdt. So drdt
Okay.
is 0.03. And you keep reading here, at what rate is the plate's area? So that's dA dt. So rate, whenever you see rate, think derivative. The radius is 46. So we're trying to figure out, drdt, dA dt are equals. So the area is pi r squared. So you have to know that. You have to know that formula.
Okay.
Like if you're in a traditional calculus class, everyone raises their hand, do you have to remember the formulas? And I mean, I wouldn't care. I just give you the formulas or just say, bring whatever you want. But
Yeah.
because there's actually research that shows it doesn't matter how many reference sheets you get on a
Yeah.
test. But teachers are like, no, you need to memorize these things. Like, I don't care. Memorize if you want to write it down. This
Yeah.
is power rule derivative. Like this pi just comes along with it. The ADT is pi times 2r. But this is what the hard part is, to remember that it's an implicit. It's a related rate. So there's a dr dt. So like whatever variable you're taking the derivative of, there's an implicit dr dt there. And again, they give it to you. They give you that number in this. So it's
So that's always there.
well, yeah, like whenever in all the problems you've done today, with there's an x, there's a dx dt, x dx
Mhm.
dt, x dx dt. There's
Okay.
just always going to be that whatever variable you have.
Mm-hmm.
So it's 2 times the radius, which is 46, times dr dt, which is 0.03. And then it says type an exact answer in terms of pi, which means this is the part that goes in the calculator. And you
Mm-hmm.
get a number and you put pi with it.
Okay. Good to know. Sorry, I'm grabbing my calculator. Oops. Times 2. 2.76 pi.
All right, so number 21, we had another one of these. How many do you have? Okay, yeah, one more. I mean, these get sort of annoyingly long.
Yeah.
Yeah, okay. All right, here we go. So new problem here. It says a spherical balloon is inflating with helium at a rate of. So whenever you see the word rate and the units help you out to figure out what it is. So notice it's feet cubed. That's a volume. So
Okay.
dV dt is 180 pi. And we know that it's positive because it's inflating, inflating, deflating. Got to be able to read the English. If you're ever not sure what it refers to, use the units. How fast is the balloon's radius increasing? So we're looking for dr dt
Okay.
when the radius is 3 feet. Okay. So now we need the formula for the volume of a sphere. Again, this is one of those that you would get from previous course. It's 4/3 pi r cubed. So you take your derivative dv dt. It's always with respect to time, by the way, it's always t. So this is 4/3 pi, and then the derivative of r cubed is 3r squared times dr dt. Is that
Okay.
okay?
Yes.
All right. So 4/3 times 3 gets just the 4. So this is 4 pi r squared dr dt. We know the value for dv dt. dv dt is the 180 pi. We know that the radius is 3. These are given. So dr dt is your variable. So you're solving for dr dt. You gotta, okay, what is this? Okay, it's 3 squared. That's 9. 9 times 4 is 36. So it's really 36 pi times dr dt. And then you divide both sides by 36 pi. Look at that. Everything cancels and you get 5 equals dr dt. And your hint here, because it just says, doesn't say to round, doesn't say to like do anything weird or answer in terms of pi. You should kind of use that from Pearson to be like, okay, this is how I do it. This is how I know my answer is right.
Mm-hmm.
All right, so surface area. All right, so surface area. So now we need the formula for surface area. 4 pi r squared is the surface area of a sphere. Something to think about. Again, putting on your reference sheet. Actually, let me drop in the chat. Of course, I can't find it. There it is. This is a 1-page reference sheet for stuff.
Okay.
Volumes, surface area stuff. So take from that what you want.
Okay.
Okay, surface area is increasing at a rate of, so we're trying to find the surface area prime. And it gets a little weird when you use two letters. Sometimes students or teachers just use one. We're looking for dA dt. That's what we're looking for.
Okay.
So the derivative of SA is dA dt. And then it's the derivative of r squared is 2r dr dt.
Okay.
That. And so we're trying to solve for dA dt. So if this is 8 pi times the radius, which is 3, what is dr dt? Well, that's what we get from the previous part of the problem.
It's 5, right?
It was 5, yeah. So you have to, if you're not given something and you need it, you probably had it from another part of the problem.
Okay.
15 times 8 is like 120 pi. And notice that the answer, if you look at your thing there, that incipient, it says type an exact answer using pi as needed. It's not as needed, it's always needed whenever they suggest that. So
Okay.
yeah, keep that in mind. Let me know when we go on to 22.
Yeah, you can go.
All right, so 22, find the linearization. All right, so linearization means it's the same as tangent line, which we did in a previous lesson. So you
Yeah.
need the slope, which comes from the derivative, which we'll do first. So you have to be able to find the derivative of this function. Now it's really a chain rule derivative. So f of x is really the square root of u, where u equals x squared plus 28. So the chain rule part is you take the derivative of the outside function, square root of u, multiply it times the derivative of the inside function. Does that sound familiar
Yes.
to you? Okay.
Yes, it
Could
does.
you tell me the derivative of the square root of u, please?
Isn't it u to the 1/2? Or is it
That's a
to
way to, that's rewriting it. You got to take a
Oh, yeah,
derivative.
yeah. Sorry. Yeah, it's 1/2 u to the negative 1/2. I'm sorry.
Yes, yes. And one thing you might want to do here, because what you said is correct. If prime of x here is exactly what you said, 1/2 u to the minus 1/2. What a lot of students do is they get into the habit of writing it this way, which
Okay.
is the same. And it's kind of a shortcut, but you do so many square roots in calculus that this is just a better way to write it. All
Okay.
right. And then you multiply by u prime. So what is u prime here?
U prime is 2x. I think it's just 2x. Yeah, it's just 2x.
It's just 2x. Good. All right, so now you put the stuff back in. So it's 2 square root x squared plus 28. U prime is 2x. Now, we talked about this idea that you only simplify derivatives when you need to use them. And that's kind of your discretion here. If you want to simplify the derivative here, you can see that it's 2x over 2 square root x squared plus 28. You can see that the 2's cancel and it's x over square root of x squared plus 28. Generally, it's good to simplify them when you're going to use them. Okay. So now all of this is to find the slope at a point. So we need to put 6 in for x. So f prime of 6 is 6 over the square root 6 squared plus 28.
Okay.
So can you go ahead and simplify that for us, please?
Yeah. It's 3/4.
Okay, that's good. So there, the next thing is we need a point. So you get the point actually from going back to the original. But it's much easier. I mean, sometimes you do the point first. So the second thing you
Mhm.
need is the point. So you have x equals 6. So you find f of 6, which is 6 squared plus 28 square root, like that. So it ends up being 8, I believe.
Mhm.
So it's when x is 6, y is 8, or you can think of it as f of x if you prefer. All right, so the linearization, L of x, like why did we do all this? So L of x is L of a, which is this f of x part, putting the, sorry, it's that's not right. It's f of a, not L of a. F of a plus f prime of a, that's the derivative we found, the 3/4, times x minus a. So it's 8 plus 3/4 x minus 6. That's your L of x. So again, we needed the slope and we needed the point.
Okay.
I think that's the only one of those to do. The rest are just some derivatives.
Yeah, I don't get many of those. I
Yeah.
don't even know. I don't even remember that being on midterm, but if it is, that's fine.
So they're randomly selected from what I remember.
Yeah.
But I don't know if they're the same each time. I mean, I did help like 3 different students with a stats class like many years ago, and their midterms were just identical.
Yeah.
But that was
I don't know if
constructor
they changed
specific.
it. Yeah.
All right, so the derivative here is it's a u substitution. So y is equal to cosine of u, and u is 9x squared. So it's a chain rule where you're so you're saying, okay, u is the inside part. You start by taking the derivative of the outside part. What's the derivative of cosine?
I'm pretty sure it's negative sign, right?
Negative sine u times u prime. And then what is u prime?
Uh, 18x.
Good.
Yeah.
So you just back substitute in. Then there's a little dx here, but that's not important. So negative sine 9x squared times 18x dx. This is what goes in the box there.
Okay.
Let me know when we can go on to the next one here.
Yeah, of course.
Okay. All right, next one. Same idea here. Y is really 3 natural log of u. So if you're ever wondering like what is the like inside function, it's like usually in parentheses. Um, all right, so dy here is 3 times 1 over u times u prime.
Okay.
And what's the derivative of u over here on the right?
2x.
Give me just a moment here. All right, 2x dx, that's right. And then the only reason I'm adding, well, that's a little odd. So in the previous problem here, see how it had the dx off to the side and this one does not?
Yeah.
It looks like you will have to add that. And it's just a small subtle thing, like
Mhm.
just be careful that you see that on the test. So dy is 3 times 1 over 3 plus x squared. U prime is 2x dx. So if we wanted to just clean this up a little bit, just to make it easier to type in, it's 6x dx over 3 plus x squared. Like that.
Okay.
Okay, let me know when we go on to 25.
Yep.
All right, the radius of a circle is increased from 9 to 9.3 meters. Estimate the resulting change in area, then express the estimate as a percentage of the circle's original area. Okay, this is, I don't know, this isn't even a calculus question. So the area of a circle is pi r squared. So it's pi 9 squared. And then the area of the next circle is pi r squared, pi 9.03 squared. So you need both of these numbers. Now the resulting change in area is the difference in them. 9.03 squared minus pi 9 squared. Since it wants an exact answer using pi, what you do is you basically ignore the pi and just do the 9.03 squared minus the 9 squared.
Okay.
So let me know what you come up with for that.
Oh, hold on. I'm entering it. It's being weird. Okay, I got 6,604.8129 pi.
There's a decimal here. 9.03 squared.
Yeah, I
Should be
have it.
like 81.5409 minus 81. I mean, it should be 0.5409, right?
Okay. I put it like completely whole in the calculator, so maybe it messed it up. Okay. Yeah, 0.5409.
Okay, so I believe that to be the answer for the change in the area. Now for the next part is the percentage of the original area. So this is a little wonky, but you take the change in area, which is 0.5409 pi. Get those numbers a little tighter together. And then you divide it by the original area, which was 81 pi. So
Okay.
that's the original. That's the change. So you notice the pi's cancel. That's good. It's just a round of 3 decimal places. And because it's a percentage, you have to multiply your answer by 100. So in the real world that we live in, nobody likes decimals. They always want percentages. This number, this problem, if you don't multiply it by 100, but it ends up being 0.668%, which is very small as a percentage change.
Okay.
So that is everything that you sent over. We've obviously got some time left. What else would you like to do today?
Let me see. There's that one. Gosh.
Okay, I see you sent something over here. It's loading up. Okay, so we got a new one here. Maybe I did miss that. This is another one of those U problems. chain rule problem. So this is really y equals cosine inverse u, and u equals 5 to the 4th, like that. Like that. So dy dx for arc cosine. Do you remember that one from your reference sheet? And you might have to memorize, some of these. But it'd be good if you
Um,
could find it, just because it's like one of those where if you don't know where to look for it, you'll miss it.
let's see. Um, would it still be negative sine x from?
No, so these are in the inverse trig functions.
Uh-huh.
Let me make sure I've sent you, drop another thing in the chat here. I mean, there's tons of reference sheets.
Okay. It's -1 over the square root of 1 minus x squared.
So -1 over the square root of 1 minus x squared.
Yeah. And then u prime is 20x to the third.
So what's odd about this one, or what's maybe a little bit different, is u is really the x. So it's all of this squared. So it ends up being times, and really I should put u here and u prime. So it's -1 over the square root 1 minus 5x to the 4th squared. And you don't have to actually square it, times the 20x cubed.
That's it.
That's it. So if you wanted to, you simplify, I mean, you could, like, let me, like, it could be -20x cubed over square root 1 minus 25x to the 8th. All right, so we got another one here. The same kind of spectrum. So y is equal to the arctan or tan inverse of u. And then u is the square root of 7p. So dy dt is the derivative of arctangent, which is 1 over 1 plus time, or u prime. And then what is, could you try to determine u prime for us, please?
Would it be 1 or 2 over 70? Is that how you told me to do it?
Well, yeah, it's 1 over 2 square root 7t, like that, but
Okay.
there's a little bit more because there's a chain rule part of this, which
Okay.
you could make it like the square root of v, and v equals 7t.
Okay.
So times 7.
Mm-hmm.
And if that's unclear, like it's really, let me do it up here. Well, actually, let me do it now. It's really u equals the square root of v, and v equals 7t. So du or u prime is 1/2 square root v prime equals 7. But at some point it gets kind of too much.
Mm-hmm.
So it's like, well,
Mm-hmm. So it'd be 7/2 square root of 7t.
so it ends up being 1/1 plus square root of 7t squared, and then u prime is around the room here. It's 7/2 square root 7t.
And you wouldn't be able to simplify that.
Well, you can. I don't think you have to, but let me get to where I can give this a little more room. So it's 1/1 plus 7t because the square root squared undoes it. And then it's 7/2 square root of t like this. I would probably just leave it like that. I wouldn't like try to simplify it. I mean, I probably would even just have left it like this, but it's kind of like,
Yeah. Okay. Okay.
I think, is that kind of take care of everything on your
Yeah.
list for today?
Mhm.
All right. Is it okay if we stop here? Do you have any more
Yeah, of course.
questions?
That's fine.
All right. So yeah, thanks again for scheduling on the website. Let me stop the recording. Why did it stop? That's weird. Okay. Oh, there it is. Yes, I want to